Every day, independent oil and natural gas producers are out there drilling smarter, going farther, and delivering the energy that fuels our economy and strengthens our national security. It's a side of the industry that's dynamic and foundational to how affordable, reliable energy gets made in America. This podcast is about diving into that world. We're talking tech, policy, production, and pressure points. Everything that shapes how American energy actually works. This is Longer Laterals. Welcome back to Longer Laterals, where America's energy story meets Washington. Today, we have a very special episode of Longer Laterals, where we are going to talk about the longest lateral. EQT, a leading natural gas producer with operations across the Appalachia Basin, recently set a new continental U.S. land record for longest lateral drilled. It's called the Longwell 9H, a well measuring over 7 miles from end to end and featuring a record-setting lateral of more than 5.5 miles. EQT completed the well with no safety incidents and kept 100% of the lateral within target formation. Joining me to discuss what it took to reach this milestone and what it could mean for the future of natural gas development is Toby Rice, President and CEO of EQT. Toby, congratulations and welcome back to the pod.
Hey, thanks, Anne. And all the congratulations go to the team here at EQT. They did a fantastic job setting this record.
Absolutely. I can't wait to hear more about it. Let's begin by level setting for listeners who may be learning about unconventional wells for the first time. Can you explain what a lateral is exactly and what the significance of longer laterals are and what the practical benefits of longer laterals are?
Yeah, so there were 2 records that were broken. I'll explain the difference in each. The first one is the measured depth, and this measured depth is the distance from the surface of the well through to the end of the well bore. So this will include the vertical section, and it'll include the curve section. We're actually bending the pipe, and then it includes the lateral section, which is contained in the shale, which is the whole reason why we're out there doing this, is to increase our lateral lengths, the presence of well bore within the shale. So that measured depth is over 37,000 feet. That's the distance that we've drilled. Now, of that, the lateral section is over 29,000 feet, is the actual horizontal section that's within the shale. That is the part of the wellbore that we will complete. We'll perform hydraulic fracturing operations, and naturally, that is the part of the wellbore that will actually produce. To give you some perspective on how much this lateral will produce in this region, we're expecting to produce over 50 million cubic feet of natural gas of production. That is a tremendous amount of natural gas that would produce enough natural gas to power a few hundred megawatts of power just from one wellbore. So this was a tremendous feat. To give readers some context on just how big of a deal this was, when the Shale Revolution kicked off, my first well in 2010 was a 2,000-foot horizontal well.
Wow.
Okay. And it took us 45 days to drill. 10 years later, the longest lateral drilled was an 18,000-foot horizontal well. And now, 10 years in 2026, we're talking about drilling over 29,000 horizontal feet. And we're doing this in a handful of days, not weeks or months. It just speaks to the innovation that's taken place in this industry. And when you step back and you look big picture, we're producing record amounts of energy in this country, over 30 million barrels a day of energy equivalent when you add up the oil and gas together. And we're doing it with less than 600 rigs. In the past, we used to run over 2,000 rigs to produce far significantly less energy. With fewer rigs, we're producing more. The productivity per rig in this country, which speaks to the innovation, has increased over 25-fold since the Shale Revolution began. That is the big picture innovation that's taking place in this industry. And these records give us an opportunity to provide some really meaningful anecdotes on the innovation that's taking place in the oil field.
And talk about what it means for surface footprint too, right? Because if you're drilling 5.5 miles under the surface. What does that mean for how many wells you have on a particular pad or in a particular footprint in a particular area?
Yeah, so standard design, if you assumed one site, we can drill from one site that would be build would be about, call it 20 acres of surface land that we would impact to create this drilling location. With 15,000-foot laterals, we can develop over 4,000 acres from that one
Wow,
investment of the 20 acres. So think about that from a land use perspective. With essentially 30,000-foot laterals, the 4,000 acres that we can develop now becomes 8,000 acres. We're already talking about a fraction of a percent of the land utilized to extract the energy from the natural resources. Um, but it allows us to continue to minimize our environmental impact, and that's been another story that we're incredibly proud of in the oil and gas industry, is that our footprint continues to shrink, our energy continues to grow.
amazing. So let's put that 29,000-foot lateral in perspective, and we'll give it a current spin. That is the equivalent of 109 soccer fields. It's just an incredible, incredible length. This has obviously been building over time. You talked about this on a previous pod. Brendan talked about the stacked innovation, which I know you've repeated and have responded to. Talk a little bit about kind of what you've learned over the years that made this possible, and maybe why this particular location was so record setting.
Yeah, this wasn't as easy as saying, "Hey, we're just gonna drill longer." This has been, decades in the making. Every one of these, records that we've set in the past sort of sets the new ceiling. We try and beat that. Um, you know, Innovations on drill bit design to make sure these drill bits can continue to drill after drilling significant amount of footage. There's been significant drill bit design. There's been significant improvements in the mud that we use. I mean, we are creating cuttings, and we need to get those cuttings out of the wellbore. So to be able to circulate and keep the hole clean while we're drilling to prevent us from getting stuck. Huge advancements on the drilling mud. Then you get through getting the casing down to bottom and the thread connections that you need to withstand the torque that's going to be needed to push this casing down to the bottom of the well. And then also on the cement, there's been advances on the cementing side as well to make sure that we can pump the cement, get the timing right so that we don't have it set too fast, make sure the densities are proper so we don't have any wellbore issues by doing this, and leaving our completions team with a wellbore that has very high integrity so that they can do their jobs and connect that wellbore to the reservoir with their hydraulic fracturing operations. Um, when you step back and you look at what we do in oil and gas, and there's over 400 different services that need to be put together to go from a field to a well that's producing gas into a pipeline. Um, and every one of those services needs to be optimized. And this example with this drilling record shows what we've done on the drilling side. But guess what? Now our completions teams needs to increase their games. How can we actually complete a 29,000-foot lateral more effectively? What can we do to make sure that we're relieving the friction so that we can continue to get our desired pump rates out to frack the toe of that well, which is the 29,000 feet is the end of the well bore. What can we do to make sure that we're drilling out the plugs after we go through the sequence of fracking and setting a plug and doing that? We're going to do that probably almost uh, over 200 times on this well bore.
Wow.
So how can we drill out more effectively? And this is just a really great example, just the innovation that is able to improve. And where we're at with drilling right now, I mean, some of the things we need to innovate now is, I mean, we're getting to the place where we're going to need to start thinking about upgrading the type of materials that we use for the well bores, like stronger steel. So we're just in another level, and we'll continue to crack those levels. It's what we've done for the last 20 years in shale. So this is just a natural evolution, but it's pretty amazing to think that after 20 years, this industry is still finding ways to push the limits. There are few bounds to our success.
Amazing. Um, safety is obviously paramount for EQT and for all of our companies. So certainly worth noting that the well was completed with zero hazard points and 100% of the lateral remained in target formation. It was obviously completed safely, regarding everyone that was involved. What kind of technologies and planning processes, and were there real-time decisions on the ground that made that level of safety and and precision possible?
Robust set of controls. Our company value number one at EQT is trust. Everything we do can be done safely. We do what we say we're going to do, and we make sure that we have a tremendous amount of teamwork and communication so that everybody understands the operation and where the issues are, and what we can do to mitigate those. There's nothing really special that we do on a 29,000-foot well that we wouldn't do as part of our base operation planning going forward. um, so for our just basic set of operations. And we're incredibly proud that we're able to do big things, but not sacrifice our safety. And we're incredibly proud of the record, but we're even more proud at EQT the fact that we did this with no environmental or health and safety issues, because that is our number one criteria. Second record is number two.
Let's maybe look forward for a moment, and think about where do we go from here? So, what does this mean for industry? What advances in drilling technology do you think will be needed to push to the next generation of development forward? And what does that mean for the future of Appalachian natural gas, but also, U.S. oil and natural gas generally?
We've got great collaboration with our service providers, that are really optimizing their services to meet the technical specifications of these new frontiers that we're pushing into. Those innovation cycles are in motion. They've been in motion for the past 20 years, and they'll continue going forward normal business. But I think the takeaway here is that this industry is continuing to be one of the most innovative industries in the world. We've got an amazing challenge in front of us, to increase our natural gas production in this country to allow the U.S. to win the AI race, to provide energy security to our allies with U.S. LNG. We need to increase our natural gas production between 20 and 40%. We have a lot of resource here, but to achieve economic returns, we need to continue to innovate so that we can lower our costs and continue to supply this energy. What we're doing with this long well is just an example that the innovation exists, and we're going to be able to unlock that inventory to provide energy security to our allies and allow the U.S. to win the AI race. And it's just something that is very encouraging that we're able to continue to innovate, and push the limits, to create safer, cleaner, more reliable, more affordable energy.
So, in a nutshell, operators are doing everything they can and, really pushing the boundaries of what can be done below the ground. We need permitting reform to make sure we can build up the infrastructure above the ground and just under the ground in order to move that product. Because you mentioned the incredible growing demand, both domestically and internationally, that we're seeing for natural gas.
Yeah, and I think you put it in the context here. I think is worth putting out there. We were able to build a 7-mile drilling underground, 8,000 feet below surface. We're able to do this. It's easier for us to do this than it is to actually build a piece of pipeline on the surface. That's something that we need to change, and that's why permit reform is absolutely critical. It should be harder to do the subsurface than it is the surface, but that's something that we need to flip, and permit reform will make that happen.
So, Toby, this particular well was drilled in Wetzel County, West Virginia. Is there anything particularly special or unique about that location?
Ann, I get this question a lot since we put this record out. People are asking me to say, Tob, how come the Permian can't drill the world records? Or how come the Haynesville can't drill the world records? Certainly, these areas, and they've got some fantastic leaders out there that will continue to push the pace. I expect this industry to continue to build on this success, and someday you could see records coming from those regions. But right now, Appalachia holds the belt, and I can't say enough great things about this crew. It's been an amazing achievement, but This achievement will be temporary. I guarantee you this. This record will be broken. The question is it going to be somebody else or is it going to be the crew? We're going to look for ways to make sure the crew stays on top. But healthy competition, all records move us forward. That's been the strength of U.S. shale. We've all built on the failures and successes of each other. And it's one of the reasons why America is the world's energy powerhouse. It's because of that healthy competition that exists.
Well, Toby, thank you so much for joining the pod today to talk about the EQT team's historic achievement and the role that Longer Laterals plays in affordable, reliable American energy. That wraps another episode of Longer Laterals. Thanks for tuning in, and we'll see you next time.